Congratulations! After a long journey during which you studied different systems, you were able to model SD, the top-level diagram of a robotics-based electric cars manufacturing system. The CEO of the company is happy, and I am so proud to be your mentor. Now the company you work for is involved in a new and exciting project, converting an electric car into an autonomous one. You were asked to model this system so the company can submit it to ISO, the International Organization for Standardization, as a proposal for a new international standard for autonomous cars. To convert a human-driven car into an autonomous one, we first need to integrate a few systems into it, including a system for monitoring and interpreting the environment. A major task of this system is to detect vehicles and pedestrians and alert the driver before a collision happens. Mobileye, which is part of the global Intel Corporation, develops and integrates such systems in many millions of cars worldwide. Here, we can see such a system in operation inside an experimental autonomous car. In the next few videos, we will learn how to model it. For an autonomous car to receive regulatory approval, it must adhere to standards that require modeling the system conceptually. Therefore, the CEO wants you to create a detailed OPM system model for submission to ISO. In this section, you will learn how to model the first detail level of every system. We called the top-level system diagram, or SD, and this was level 0. The first detail level is called SD1, and this is level 1. At this level, we specify what processes make up the main process from SD. Here, we also refine objects from SD. Recall that SD answers the big questions about the system: its purpose, main function, enablers of the main process, the system's environment, and how the problem it solves occurs. In SD1, we start fleshing out the system by specifying details about its structure, behavior, and function. Here comes Hopcat, who is so helpful with definitions.
SD1, an OPD which is a descendant of SD, in which the main process is refined, exposing its subprocesses and objects associated with them. Detail hierarchy OPM principle. Whenever an OPD becomes hard to comprehend due to an excessive amount of details, a new descendant OPD shall be created.
To begin learning how to model SD1, let's look at Mobileye, a system that monitors the car's environment, detects vehicles and pedestrians in the front, and escalates alerting the driver before a crash is imminent. A common scenario is a car getting closer and closer to the car in front of it. Here, several processes occur in sequence, one after the other. First, the system detects a car in the front, but being far enough, it doesn't alert the driver. As we get closer to the car in front, the time in seconds needed for stopping is displayed in green. As we get even closer, the braking time is displayed in red and a single short beep is sounded. Finally, if we come to a crashing distance, a big red car icon is displayed and we hear several frequent short, loud beeps. We can see that the main process we described is comprised of 4 smaller sub-processes occurring in a fixed order: detecting, informing, alerting, and crash alerting. A process whose sub-processes occur sequentially in a fixed known order is a synchronous process. Here are 2 examples of synchronous processes, one in a technological system and the other in a natural one. Airplane flying always starts with takeoff and ascending, continues with cruising, then descending, landing, taxiing, and finally parking. Tree growing always starts with germinating, continues with seedling, sapling, and maturing, and it ends with decaying and withering. In contrast with a synchronous process, an asynchronous process comprises sub-processes that are not dependent on each other and can occur in any order. For example, in an email managing system, the main process is email managing. It comprises sub-processes that have no specific order of occurrence. We can, for example, send a new message, read some messages in our inbox, or delete spam messages. These processes refine the main process, but do not occur at any particular order. Another example of an asynchronous process is shopping at a mall. We can buy clothes before we buy electronic products, then do some window shopping, but the order in which we do it is immaterial. The operation of the human brain is also asynchronous, as many different complex processes happen within our heads in parallel and in numerous various sequences. What about this MOOC? Is your learning process synchronous or asynchronous? That depends on your learning style. Some of you learn this course synchronously, according to the prescribed order of the various learning activities, while others might go back and forth in case they want to make sure they fully understand some topic. This is an example where a process can be modeled either synchronously or asynchronously. Like processes, objects can be refined too. For example, in the Mobileye model, we might want to specify the system's camera and computer. Unlike processes, which are dynamic and time-dependent, objects are static, so synchronicity is irrelevant for objects. Let's summarize. We learned how to construct SD1, the first detail level of an OPM system model, which refines things in SD, providing more information about the system's function, structure, and behavior. We also learned about synchronous and asynchronous processes and how they differ from each other. In the next videos in this section, we will learn how to refine OPM processes and objects as we learn more about the Mobileye system. See you soon!